Okay, so to introduce Gene is really an easy job and probably unnecessary. We all know Gene and what he means to us, all right? So, but nonetheless, Gene, I'm really honored that you have asked me to do this. Yeah. I first met Gene at a nucleic acids Gordon conference in the mid-1960s. I think it's 65, Gene, maybe?
Very likely.
Yeah, it's 1965, yeah. Now, you might wonder why Gene was at the nucleic acids conference, because we all know Gene for the work that he has done on vitamins and coenzymes, folic acid, thiamine, riboflavin, pteridines, pantothenic acid, whatever have you. But Gene had come back from a sabbatical with authority at Caltech and had become interested in nucleic acid methylations. And that's really what brought him to the Gordon Conference on nucleic acids. But even though I met Gene only in 1965, I had known of Gene and his work a long time before. Yeah, I had gone to England to do my graduate work in 1956 in Jim Baddeley's lab, and I was given the job of synthesizing coenzyme A. And there I had to read Gene's graduate papers from his graduate work on pantothenic acid, pantothane, and conversion of these compounds into coenzyme A. So I knew Gene already in 1956, at least his work. Yeah. I next met Gene when I came here for the interview, and then I've got to know him really well as a colleague and as a friend since 1969. Now we all know that Gene is widely admired for his intense devotion to teaching and to administration at MIT and in the department. We all know that he came here, what, 53 years ago, Gene? 53 years ago. But even more remarkably, he's been teaching, and he's been a consistent teacher of 705 since he arrived here for 53. So he's been teaching 705 for 53 years. And and also he has been teaching an advanced biochemistry course, which he now teaches on his own. So when I meet people and talk to people, students and others who have long since left MIT about 705, the sparkle comes to their eyes. They say, oh yes, Gene Brown's course. So
your course too.
Well, Paul Schimmel came by and stopped for lunch. We had lunch together, and one of the first questions that he asked when we sat down was, how's Boris and Gene doing? I said, they're both fine. They're both still teaching, and Gene is still teaching 705. And Paul says, oh, really? Unbelievable. So that's really a remarkable record. And on the administrative side, Gene became the associate head in 1967 when Boris became the head of the department. Gene then became the head in 1977, moved on from there to become the dean of science from 1985 to 1991. And so he's been an administrator for, besides not being doing research and all that, administrator for pretty close to 25 years. So that is, again, a remarkable record. And it was really at this time that the Centers for Cancer Research and the Whitehead Institute were established. And so these were the two major expansion events in the department. And Gene was either the associate head or the head during that time. So that's, again, a tremendous administrative contribution. Looking back, I can say that early on, what I really learned one very important thing from Gene, and that is that teaching was important. And he showed me how to do it, at least strive to do it right. I had the pleasure of teaching 705 with Gene for close to 22 years, I think it was, with 1 or 2 years in between where someone else came to teach it, and I taught it with Frank. And during that time, one of those years, I went to all the lectures that Gene gave. And I not only learned real biochemistry, really, but it was an awesome experience to watch all the 9 blackboards in 10 to 50 filled with structures and mechanisms and pathways with not one word out of place, and all, just looking back from there, all very, very clear. And so, Gene and I spent many hours working on exams, grades, and things like that. And I really learned what teaching is all about and what commitment to teaching is and why it is important. So it comes as no surprise to me that Gene is among the most widely admired and well-liked among the teachers at MIT, and that he consistently got high evaluations. I know that because I never came up to him. And he was also, I think, Gene, correct me if I'm wrong, you were among the first batch of Margaret McVicker Fellows at MIT.
Close. Well, not quite.
Not quite.
Monty was one of the first.
Oh, Monty. Okay, Monty. All right. Okay. Yeah. So I think, I don't want to take much of Gene's time here. Gene has, as I've already mentioned, has been incessant promoter of the importance of teaching in the department. So I think it's most appropriate that last year his former students and postdoctoral fellows got together and raised the funds necessary to establish a teaching assistantship in Gene's name. And I thought that was the most remarkable and the most fitting tribute to Gene. And I suspect that Gene also is quite happy about it. Right. So there's Gene. I know, I'm sorry, Mandana reminds me. Yeah, here is something that Mandana got from some of the students, undergraduate students, right? I would really love to hear Professor Brown talk about his life and his experiences in research and at MIT. I had him for 2 classes, and I was astounded by the amount he knows and can lecture about, almost entirely without notes. Unfortunately, I'm not going to be back at MIT until Wednesday, June 27. I wonder if there would be any way to have his talk recorded and stored so that those of us who miss it would still be able to hear him speak. I am sure there are many in the same situation. So that's a remarkable thing to get, right? Gene, congratulations. Now, I also want to ask how many are undergraduate students here? Yeah, I thought I recognized some. Okay, so remarkable. Yeah.
Thank you, Tom. I didn't realize I was so important. Okay, I'm here, ready for questions. Anybody have a question or comment?
Tell us about your early life.
My early life. Okay, Bob. I was born in the Ozarks, in southwest Missouri, and thus I have somewhat of a twang, I guess, I've been told, to my speaking. That was during, I was born in 1926, and in 1935, my father and mother took their 2 children, I was the older, my younger brother, to Idaho. This is during the Depression, when people were having a hard time making a living in that area of the country. They thought they would do better in another area, so they moved to Idaho. So at the age of 9, we settled at a little farming village in Idaho, population 120. And I received my elementary and high school education in that little village. There were 17 in my high school graduating class. I have to say that I was never challenged in elementary or high school in that little school. In high school, it was during the first part of the Second World War, and the teachers at that time were not very good. They were substitutes, because other teachers were gone. So I was never challenged in high school. When I graduated from high school at the age of 17, I enlisted in the Air Corps, Army Air Corps, at the age of 17 because I didn't want to be drafted into the infantry. And I enlisted for pilot training. Now, they didn't call, at that time, they never called people up until they were at least 18. So I had a year that I spent at a little liberal arts school in Idaho. And so I had 1 year of college before I was called up into the Army Air Corps. And I decided at that time to major in chemistry while I was that 1 year at this little liberal arts school. By the time I got into the Army Air Corps, they decided they didn't need any more pilots. It's toward the end of the war. So they asked me what my interest was, and I said chemistry. So they said, okay, you're going to be in chemical warfare. So I found myself at the age of 18 lecturing on chemical warfare before basic trainees, about 400 to 500 at a time, about how to protect themselves against war gases and so forth. And it was then that I realized how nice it was to have a captive audience. And I kept that in mind for the next several years, in fact. When I got out of the Army, or in the meantime, I should point out that my mother and father were separated when I was 15. So I'd been making my own decisions all by myself since the age of 15, actually. I was the first person in my whole family who ever went to high school, incidentally. So, you know, my mother and father didn't know how to advise me about anything or to stimulate me in any one area. So that was left for other people. I had the GI Bill when I got out of the Air Corps, and it allowed me to get my last 3 years of college. I went to school at a Cal College in Colorado, called Colorado A&M at that time. And I went there because my best friend wanted to be a veterinarian, and that's where he wanted to go because he said he thought he'd get into vet school more easily there if he went there as an undergraduate. And I said, well, I don't know where to go, so I'll just go with you. So I did. I went there and majored in chemistry. My GI Bill was just enough to let me get through 3 years of that was required to get a degree. The first term of my senior year, I enrolled in a course in biochemistry because I had one more course to take in chemistry. And that was the only one that fitted into my schedule. About halfway through the term, the professor called me into his office. And I went in with trepidation. I thought, gee, what's going on here? I thought I was doing pretty well in this course. The first thing he said to me is, you ever think of going to graduate school in biochemistry? He said, you have a real knack for this subject. I said, I can't go to graduate school because I don't have any money and the GI Bill is running out. He said, well, if you're good enough, and I think you are, you can get a fellowship to go to graduate school. Now, you have to keep in mind, I was very naive at that time. I didn't know what he was talking about. You know, I grew up in that little village in Idaho and where nobody ever gave you anything. And he said, well, they'll give you money to go to graduate school. I said, gee, Aaron, what do I have to do? And he said, well, you ride off to Cornell and Wisconsin. He said, those are the two best biochemistry departments in the country. You have to keep in mind that he was a nutritional biochemist. And Cornell and Wisconsin was both very, very strong in nutrition at that time. And he said, you ride off and ask him for a form to come to graduate school, PhD training, and tell them you can't come without a fellowship. So I did. I got the forms back about the same time to fill out. The one from Wisconsin was easy to fill out. I filled it out and sent it back. And I was still trying to get all the information together from Cornell for the application when I got my acceptance at Wisconsin. I never bothered to send anyone in at Cornell. Got my acceptance at Wisconsin with a WARF fellowship. They only gave those 2 fellowships per year at that time in biochemistry. And I didn't know that at the time, but then when I arrived there at Wisconsin that summer, I met with the committee. There was a committee that assigned you to a particular faculty member. And you didn't have any choice about it, in fact, at that time. So they met and assigned me to Esmond Snell. which was the best thing that could ever have happened to me, frankly, because Snell was a real biochemist, trained in chemistry. He, at that time, was working on the nutrition of bacteria, bacterial nutrition, and he was isolating and determining the nature of growth factors that were needed by certain bacteria. And after, when I entered graduate school there, I realized immediately, it didn't take me long to realize this, that my background was not nearly as good as all of the other entering students at that time. So I was worried, afraid I wasn't going to be able to make it there. And in fact, after a couple of months, I had more or less decided to drop out because I thought I was in over my head. And I went in to talk to Esmond about it, and he talked me into staying. And I'd say within 6 months or so, I had caught up with everybody, and had passed most everybody, in fact. And I tell this story particularly to students because there's no substitute for ambition and for the willingness to work hard when necessary. And that's what I did. I mean, I was there 7 days a week in the laboratory. I was working sometimes 15 to 18 hours a day, and was assigned a project that was a very hot project at the time, and I was interested in it, and Snell was an excellent mentor. He taught me how to be a professional scientist. There are two people in my life that I'm indebted to. The professor at Colorado A&M, who guided me to graduate school. His name was Ray Patton. I'll always be in debt to him. And Esmond Snell, who taught me how to be a professional scientist. I got my degree in 3.5 years, a PhD, and I stayed on an extra year with Esmond because I had something going that he wanted me to finish. And so he paid me as a postdoc for the extra year. And during that extra year, Jack Buchanan called Esmond Snell and said, I've just arrived at MIT, and I want to hire a young biochemist. Do you have anyone you can send me? And Esmond said, yes, I do. And that's how I got to MIT. I arrived here in summer of 1954. That year was a very interesting year for me. Within a 12-month, about a 14-month period, I got my PhD, married the woman of my life, and got a job here at MIT, and got my wife pregnant. And bought my first car, incidentally. So I arrived here in 1954, and I've been here ever since. I was assigned immediately the job of organizing and teaching a laboratory course in biochemistry by myself, and also giving several lectures in general biochemistry. At that time, 705, general biochemistry was known as general biochemistry and physiology. And it was team taught in the medical school tradition because Jack Buchanan, who had arrived from medical school in University of Pennsylvania, had the medical school tradition of team teaching. So I only had about 5 or 6 lectures to give at that time in the course. And it was clear that, with 6 or 7 people teaching the course, that it was just a mess. So over the next few years, 1 or 2 people would be dropping out until finally there were only 2 of us left. And those 2 had turned out to be Vernon Ingram and myself. And in 1959, after Vernon arrived here, he and I taught that course together for several years until Tom arrived. Then Tom and I taught it together for several years. And then Peter Kim and I taught it together. And now Mike Yaffe and Dave Bartell and I are teaching it together. I taught the laboratory course and the lecture course together for several years. While I was trying to, of course, win tenure at MIT. I didn't have tenure yet. And I was absolutely sure I would never get tenure because I just didn't have the time to devote to research that I thought I should have because of the teaching responsibilities. So I went in to see Salva Luria, who had been here just 2 or 3 years at that time, and to talk to him. And I said, you know, I don't think I'm going to get tenure here. Would you be helpful in trying to locate me somewhere else at some other institution? And he said, well, why don't you just wait a while and we'll see what happens. I don't know whether he knew something or not, but anyway, I did get tenure. And I've been here ever since. Is there anything anyone wants to know about me other than what I've told you? Yes?
For us young undergraduates that have a very small idea of what it is to do scientific research, possibly only 2 or 3 years, can you try to give us some scope as to how scientific research has evolved over the course of your career of almost 60 years?
I don't know that it's any different than when I started. I mean, it just takes a heck of a lot of time. And I tell graduate students sometimes that research is 90% drudgery and 10% glory. And for those of us doing research, the 10% was enough to keep you going. And you know, you just have to work hard doing research and you have to keep at it. And you never know when the breakthrough is going to come on a research project. You just have to keep at it. And I don't know that it's any different now than it was 53 years ago, or 55 years ago, 56 years ago when I first started doing research. You just have to keep at it and keep an open mind about everything and know what to do and when to do it.
How do the current students at MIT compare to the ones of many years ago?
The question is, how do the current students at MIT compare with the students of 50 years ago?
Yeah. Are they getting better? Is there any evolutionary process?
Actually, I think they're getting better. I really do. I think the undergraduate students that we admit these days are very intelligent. They were very intelligent 50 years ago too, but now we have, the difference is that more than at least about half of the students we admit are females. And in those days, 50 or so years ago, about 10% of the population, the student population, undergraduate population was female. I mean, we hardly ever had a female student taking biochemistry in those days. We were graduating, in the mid-1950s, we were graduating about 10 students per year with bachelor's degrees in biology. You know, nowadays we're graduating 70 or 80 per year, and 10 or 12 years ago we were graduating more like 140 or 150 students per year, undergraduates. That was before Brain and Cog had an undergraduate program and before biological engineering had an undergraduate program. So we had a lot more undergraduates. All students interested in biological sciences were biology majors 15, 20 years ago. I would say one difference I see in the undergraduate population is that the students that we admit now, to undergraduate students that we admit now, have a more diverse interest than they had 40, 50 years ago. And therefore, I think, are a little bit less willing to concentrate intensively on one particular area. You know, they say, well, you know, I like biology, but I also like chemistry, or I also like business or literature. And so I think they have a more diverse interest now. That's not too surprising because the MIT administration had decided several years ago to try to admit students with more diverse interests. And it's been the case, in fact. Nevertheless, the students that come here, the undergraduate students, are really very intelligent. I told one of my classes a couple of years ago, I said, you know, you're all much more intelligent than I am. And they said, oh, no, no, no. And I said, yes, it's true. It really is true. You are, and I meant it. But I said, you have to keep one thing in mind. I'm wiser than you are now. So you better listen to me. And I was serious about that. I think the students are very intelligent.
Looking back over your career, is there anything you would have done differently if you could have been in total control of your life?
I guess the answer is no, frankly. I mean, I obviously enjoy teaching. When I was Dean of Science, I was the only teaching dean at MIT. Teaching always came first for me. Research was up there too, but I always liked to teach. Always felt that that every year you have to learn something more about teaching, and it's true. All of you are teachers know that unless you learn something every year to make your teaching a little bit better, then you're not improving. And I even enjoyed being an administrator. I enjoyed being department head. I looked upon being department head as my role as making it easy for the faculty members to do what they want to do, and to make sure that that the teaching was done properly and done as well as we could. And I tried to keep that in mind when I was Dean of Science as well. That my role would be to make sure that every department was well staffed with good department heads, and tried to give them as much as I could as dean to allow them to do their thing. So I don't think I would change anything, really. I did enjoy everything. Although I will say, you know, I used to go home with headaches once in a while, particularly when I was Dean of Science. There were times when I said, what am I doing here? The real problems, the most difficult problems that I faced as Dean of Science were the sexual harassment cases, where one person would allege, the other person would deny, and there's no third-party evidence. So what do you do? Very difficult. And I had several of those to deal with at the time. And of course, when I was Dean of Science, I had the Baltimore affair to deal with too, and you all know about that. And that wasn't easy. I had to testify before a congressional committee about that one.
Why don't you tell us about that?
Well, it all started, as far as I was concerned, when Margaret OToole came to see me when I was Dean of Science and said that she thought a mistake had been made in a paper that had been published by with David Baltimore and Teresa Imanishikari as co-authors. And so I questioned her and I said, are you alleging fraud? Because if you're alleging fraud, then I have I know how to handle it. I'll appoint a committee, we'll investigate and so forth. And she said, oh, no, I'm not alleging fraud. She said, I just think a mistake has been made and I'd like to see it fixed. So I said, okay, in that case, I can handle it a little less formally. So I said, how would you react if I asked Herman Eisen to take a look at the paper and to make a report about it? She said, that'd be fine. So that's what happened, Herman. I got Herman involved. I'm sorry about that, Herman.
Bit of an analogy.
But of course, Herman said the mistake had been made and probably needed to be fixed. And I think it would have stopped right there, you know, with Baltimore and Nishikari being willing to say yes, a mistake was made in here. Except Charlie Mapplethorpe got involved, who was a graduate student in Teresa's laboratory, and he contacted two people at NIH who had set themselves up as as two people who were looking into fraud in science. And once they got a hold of it, they just ran with it, and of course, everybody, so many people got involved, and we had this congressional committee that John Deutsch, who was provost at that time, and I had to go down and testify before the congressional committee. Margot alleged down there, she testified before the committee right before I did. She alleged that she went to see me and I told her I could do nothing for her. I could do nothing. And I was just sit there and said, what? and of course this went on for several years. The Secret Service got involved and all sorts of things. And finally, the NIH appointed a blue ribbon committee to take a final look at it. And they made a final look at it and said that no fraud had been committed, and exonerated David Baltimore. Incidentally, Baltimore and Nishikari had published a retraction by that time of the one thing that was flawed. And so it was finally settled, but you know, a whole book has been written about this. And I got involved because I was Dean of Science. And that was one of the worst things that happened to me when I was Dean of Science. The other thing, a bad thing that happens when I had to abolish a department when I was Dean of Science. Department of Applied Biological Sciences. I remember well the provost and the president and I met one day, and they said to me, wouldn't it be a good idea to abolish this department? and I said, I think it's probably would be reasonable. And I said, don't you think? And so they said, okay, you do it. and I said, don't you think maybe we ought to get in touch with the visiting committee of the department first? No need for that. Get it done as soon as possible. I was the fall guy. I abolished the department, and some of you were around at that time and know what happened. Lots of faculty meetings and so forth. And I really took it at that time because I was the fall guy. The president and the provost both said they didn't know exactly what was happening. And so I decided at the time to get it done as soon as possible, and I did. They said don't go to the visiting committee, just do it. So I did it. I quit very quickly. I had each faculty member of that department in and talked with each one and told each one what I had in mind, that I was going to transfer you to another department at MIT. So all of them got transferred to other departments. Biology department took several, chemistry department took several, and nobody who had tenure left. Some of them who didn't have tenure went to other departments. Some made tenure, some didn't in the other departments. Most of them didn't. And what's left of that department went into chemistry department. Some came here, and now some of them are in the new biological engineering department. I'm sorry, I got off of here.
They got the number of the department.
They resurrected 20, course 20. There's biological engineering. That used to be ABS, Applied Biological Sciences. And before that, nutrition and food science. And before that, just nutrition. No,
No.
for that, just food science, food technology, sorry. Anything else you want to know about me? Questions? Yes, Sarah?
Can we go back a few questions? Can you tell us some of the things that you have learned about teaching?
Pardon me?
Can you tell us some of the things that you have learned about teaching? I mean, not all 53 years.
Okay. What have I learned about teaching? First of all, you have to like to do it. And you have to develop, you must develop your own style of teaching. Make sure that you, first of all, that you talk loud enough so people can hear you. Secondly, talk slowly enough so people can understand what you're saying. And that's true of any of you who ever give talks, incidentally. And you have to really want to do it. And you have to, and I was serious when I said you should really try to learn something every year about how can you do it better. I teach without notes because, first of all, it makes an impression on the students and they think, well, if he knows that and he doesn't have to look at notes, it must be important. Therefore, I'm going to try to learn it. And secondly, most recently what I've been trying to do is to create a more friendly and relaxed attitude in the class. And in both classes that I teach, if I can. And try once in a while to tell an anecdote or something or other. And it's true that I do once in a while say something about what I did in my background, as the undergraduate student implied in what Tom read. And just try to make things as interesting as possible. And be sure, if you put anything on the board, be sure that you put it on there so that people can see it and they can follow it. And then try to explain it after it goes on the board. Explain what it is, how important it is to other things that have gone, that you have presented earlier, and try to show the connections between what you're giving now and what you gave earlier. In other words, try to see the big picture. And it's not easy to try to teach to show the big picture, because students intend to learn things in packets. And sometimes they don't understand how this packet relates to that packet, you see? And so it's the job of the teacher to try to point that out. And I must say that I don't think I have managed to do that as well as I should from time to time. So one of the things I'm going to try to do this coming year is to do better with that.
Gene, I think you didn't point out another important thing you did. When you took full responsibility for 705, it shifted from being a course in the senior year to a course in the sophomore year. It sounds like something not so important after all. Does it matter? You teach it. But it was really a total change, because it meant that biochemistry was a foundation. We go from there, and of course we still have the rule that any course that counts for or restricted electives for students has to have biochemistry as a prerequisite. So it changed the whole concept of how biology should be taught.
Right. Our whole concept of teaching in this department evolved, as Boris has correctly pointed out, over the years, so that biochemistry, which used to be taken by seniors, genetics was taken by probably seniors, juniors or seniors, and we evolved to the point where biochemistry and genetics became sophomore subjects, because those are the two subjects upon which everything else is built, and in biological sciences these days. So that was an evolution that took place over the years.
Gene, did that happen at about the same time that, the biochemistry and genetics was also taken by first-year graduate students for many years?
That's right.
Did that happen about the same time that the graduate students didn't have to take it?
It happened before the graduate students didn't have to take it. I mean, the graduate students had to take 705 right up until I was department head, in fact. Right through the time I was department head. And when I became dean of science, the department decided they wouldn't make graduate students take 705. I will have to tell you that I think it was a mistake, but that's just my own opinion.
And the biochemistry course was substitute.
You see, the trouble is other institutions around the country in undergraduate curricula don't teach the same kind of biochemistry to undergraduates that we teach here. So the graduate students who come in here have had a biochemistry course, maybe have had one and maybe not, but their biochemistry course has not been the same as the course that we give here to our undergraduates. And I see that from time to time because I have teaching assistants who are graduate students. And they were very, very clear to me. They say, we have to learn this subject as well as the undergraduates do, because this is not what we had as undergraduates.
What's the difference?
I think biochemistry as we teach it here, first of all, is grounded in organic chemistry, part of it. And that isn't true in other places. Biochemistry is not grounded in organic chemistry. And biochemistry in other places probably has become a course in nucleic acids.
Well,
Get very little metabolism
yeah.
and enzymology, and thus very little organic chemistry.
So they don't do electron pushing very much in other biochemistry?
That's right. They don't. The graduate students, TAs, have to learn that.
No, I'm familiar with what they do at Harvard in the undergraduate program, because I'm a tutor in biochemical sciences too. And basically, the chemists teach whatever intermediary metabolism is taught. It's part of the organic chemistry course.
Mm-hmm. It's an organic chemistry
and
course.
It's a tendency that's more and more true in many places.
Monty?
Well, I was going to ask you earlier about the level of funding in biological sciences has gone up enormously over this time.
Yeah.
Clearly, you were busy working back 50 years ago. People are working hard now. Where do you see the effects of those changes in funding? Do you see it simply in greater productivity per lab, larger labs, maybe not so much greater productivity? How do you see what it's like to do research at a time where the funding was considerably less than it is today?
I don't know, because I gave up my research program when I was dean of science, so I have not been faced with the prospect of getting a grant renewal every 3 years or so. So I don't know for sure how to answer that question, but I do know, of course, that last year or two, that funding at NIH has gone down. That is to say, the amount of funds available is not what it used to be. So it's a lot more difficult, I guess, to get funded now than it used to be. But we had, my first grant was National Science Foundation grant, NSF, and and a little bit later I had an NIH grant as well, of course. But funding was never a real problem when I had a research program going. That is, it wasn't a problem for me. It may have been a problem for other people. I don't know. I know it's getting to be a problem now. I'm sorry, I just can't quite answer your question. Bob?
Yeah, Gene, you mentioned earlier the breadth of some of the undergraduate students, and I was thinking about your own breadth. Can you say a little bit about interest beyond biochemistry? Because I know I've learned many things from you that would not be labeled biochemistry.
When I entered undergraduate school, I thought I would major in history. I like history. Always have liked history. I still do. As an undergraduate, though, I decided that it would be a lot more difficult to make a living as an historian than as a scientist. So I made the decision to be a scientist instead of an historian. But Boris and I both have history as avocations. And I read history books like most people read novels. I like history. That's the one thing other than biochemistry that has really piqued my interest. I particularly like Civil War history. This country, the Civil War transformed this country into something quite different than it would have been otherwise.
Since you brought it up, my interest in history too, I don't quite believe you when you simply say that you could make a living as a scientist but not as a historian. I think it takes more. We are both historians out of avocation. We like to read. But I don't know, I know I wouldn't have the patience, I know whether you would have it, to really do historical research the way you do scientific research. That is, go to the sources, find out what is available in which library or in which connection of different towns, in manuscripts, or in old records from which history is really woven.
I sort of had in mind teaching history eventually, rather than being a real historian. And I thought, well, maybe it might be more difficult to get a good job teaching history than teaching science. Yes?
How about history of science?
Good question. I've not concentrated on history of science. I've concentrated primarily on political history. But there are a lot of people, of course, who are very interested in history of science. Maury's sister, for example. Yes?
I'm sure you spent many hours at MIT, including weekends.
Doing what?
Including weekends. You spent many hours at MIT to support your career. Do you feel like you sacrificed time with family in order to support this career?
Of course you sacrifice family. I mean, anyone who has a career has to make some sacrifices to the family. Initially, when the first few years at MIT, I worked 7 days a week. Here, I came in 7 days a week here at MIT. And my poor wife had to take care of the children. After I got things established and had several graduate students and postdocs, I finally gave up coming in on Sundays. And then several years later, I finally gave up coming in on Saturdays. So I use Saturdays and Sundays both sometimes, most of the time in fact, to deal with my children, who by this time were early teenagers, when they really required my attention. It does take away, unfortunately, it does take away time from your family. No question.
You come in very early. I mean, how did you set up that schedule?
I've always been an early morning person. That goes back to my days in Idaho, because farm work started at, well, you had to be in the field at 7 a.m. That means that you had to be there and hook up the horses and so forth before 7. So you were expected to be in the field at 7 o'clock, and it was a 12-hour day. And so I just got used to getting up early. When I was a graduate student, I was usually in the laboratory about 4 a.m. in the morning when nobody else was there. And that was quite nice because I didn't have to fight with people for spectrophotometers and things like that, you see. I had the laboratory all to myself. So I've always been an early morning person. I still am. I usually am here by 4 o'clock in the morning. That allows me to leave early afternoon, you see. That way I miss the commuter traffic both ways. Method to my madness.
You might also want to point out a lot of times we start at 7:05 early on.
Tom and I started 7:05 at 8:30 in the morning. And then when Peter Kim started teaching with me, Peter said, I absolutely cannot be there that early. So I had to switch it. So we started at 9:30. And we're still doing it from 9:30 to 11, even after Peter left. You didn't object to 8:30, did you? But
I used to give lectures in Wisconsin at 7:40.
I used to have classes at Wisconsin at 7 o'clock in the morning. I was absolutely flabbergasted when I came to MIT, and faculty members and students were complaining about 9 o'clock classes. It was too early. I thought, for heaven's sakes, I mean, I had 7 o'clock classes at Wisconsin. I couldn't believe it.
Tell us about your involvement with the graduate program here at MIT.
With the graduate program? Well, I think I've had 28 students get their PhDs with me over the years. And I've had several postdocs as well. But the graduate program, when I arrived here in 1954, I think there were maybe 8 or 9 PhD candidates in the department. It was a very small department at that time. I was the 14th faculty member at that time in the department. The only person in the department at that time with a national reputation was Frank Schmidt, who was the department head. And Jack Buchanan had arrived just a year before I did, and he was in the process of becoming a nationally prominent, but with his work on the biosynthesis of purine nucleotides. But he hadn't quite achieved that rank yet. So there were about a dozen graduate students in the department, maybe, and maybe another 7 or 8 postdocs in the department. Incidentally, I should point out to you, and I'm sorry to have to report this to all of you, but Jack Buchanan died yesterday. I just heard that 15 minutes before I came down here this morning. So that's a real shock for me because I wouldn't be here without Jack's hiring me as his first. Jack headed what was called Division of Biochemistry within the department at that time. He was brought in to organize a division of biochemistry, and I was the first person that he hired. And Vernon Ingram was also a division of biochemistry, and Phil Robbins and Lisa was hired into that division of biochemistry as well. The division of biochemistry was abolished in 1967 when Boris became department head. We felt that we didn't need it anymore. See, what did I get? I got off the mark.
Other aspects of being involved with the graduate program.
Graduate program, right. Well, mainly my aspects of being involved was supervising the graduate students that I had in my laboratory, which is something that I enjoyed, particularly if they were good graduate students. I always knew when a graduate student was approximately ready to write his or her thesis. When I go in and suggest an experiment to the graduate student said, "Oh, I did that experiment yesterday." Then I know that they're thinking for themselves and they're getting well prepared to go out on their own at that time. And when I had a graduate program, I always had anywhere from 3 to 6 graduate students in my laboratory, and usually a couple of postdocs. I never wanted a large program. I never wanted more than 8 to 10 people to supervise. As opposed, the chemistry, the organic chemists always have about 20 to 30 PhD candidates in there. I don't see how they can possibly manage to mentor that many people, but it was a strain for me to mentor 8 or 9 people. But I enjoyed mentoring graduate students, and most of them went out and got good positions elsewhere when they left here, usually postdocing for a year or 2 first. In the graduate program, as far as teaching was concerned, up until the 1970s, all the graduate students had to take 705. And I started, along about that time, I started also teaching the advanced course in metabolism, which was originally just for graduate students. And most recently, graduate students who come here are not that interested in enzymology and metabolism, so they don't take the course. But I still have about 30 students per year in that course, and they tend to be, for the most part, juniors and seniors, undergraduates, who have liked my part of 705 and done well in that part, and want more of the same. So I liked having graduate students. I enjoyed being a mentor, and I hope I was a good one. I don't know for sure. You'd have to ask them.
Before you were department chairman, you were executive officer when Boris was chairman for quite a long time, and I thought that was a
10 years.
Pretty remarkable partnership. I wonder if you just comment on that, because I know that position still exists in the department. Tom is doing this now. But.
Well, I have to say, because Boris is sitting right here, and you can correct me if I'm wrong, or if I have it wrong, but Boris and I worked well together. He is department head, and I as first executive officer, and then finally associate head. We used to talk almost on a daily basis about departmental problems and issues, departmental issues, so it was, as far as I was concerned, I was being mentored by Boris, and he let me do quite a lot of the day-to-day activities of running the department, and I enjoyed that and appreciated it. It gave me the kind of experience I needed to be department head. And I should say that along about that time, I came up with several things that I used to guide me as an administrator. One is be a good listener. Secondly, have an infinite amount of patience in dealing with people. Thirdly, don't lose your temper with anyone, because the minute you do that, you destroy lines of communication with that person. Don't let your ego get in the way of doing your job. And if you have to make a controversial decision, be sure that if somebody asks you why you made that decision, be sure you tell them why, and not merely because I was department head or I'm dean of science. And I think I would have to say that in my 16 years as administrator, I don't believe I ever lost my temper once with any person. I was provoked many times.
No, I must say that Gene has much more administrative talent than I. It shows very clearly that he also became dean afterwards. Nobody would have ever considered me for that. So it worked quite well, because I was interested enough in changing, and I think we had the same ideas about how teaching programs should be arranged and how to also deal with problems of the faculty. The only administrative thing, the only rule I have, is the only one that's worthwhile, I think, is never to go in the faculty meeting without knowing what's going to happen.
Yes, exactly. That's what Boris taught me. That's what Boris taught me, and it's certainly true. Never go into a faculty meeting with an issue that you bring up unless you know how it's going to be resolved. And you know that I was, for example, I was department head when the Whitehead Institute was formed, and I knew exactly when we had the departmental meeting to decide whether or not we would be in favor of having a Whitehead Institute. I knew exactly how many votes would be no. So I went in knowing there would be 7 no votes, and that's exactly what it was.
Gene, a while back there was a faculty lunch almost every day. I was wondering, when did that start? Did it start naturally? Did someone decide, look, let's get together?
We used to have dinners.
We used to have faculty, well, we used to, first of all,
Like Friday afternoon.
yeah, Friday afternoon. When I was department head, it was well known, I made it well known, that every Friday afternoon, late afternoon, I would go over to the faculty club.
Before you were department head, though.
Even before that, okay. When I was associate head, yeah. That I would go over to the faculty club, and any faculty members who wanted to come over there, and we would sit down in a nice, relaxed attitude and talk about whatever would come up. More often than not, it would be departmental issues. And that happened every Friday afternoon. That persisted until I became Dean of Science. Then, of course, I couldn't do things like that.
The faculty club changed, too, I think.
Yeah, faculty club changed, too, and that made it more difficult. But those were nice days. Those were wonderful meetings that we had over there.
And you played basketball.
I played basketball with the graduate students. Yeah, and we used to have the faculty lunches in the lunchroom too. Remember, we would all gather in the lounge there in Building 56, and whoever wanted to come to lunch was welcome. We'd have anywhere from a half dozen to sometimes as many as a dozen faculty members there for lunch, and we would talk about whatever came up. Sometimes science, sometimes not.
Sometimes history.
Sometimes history. More often than not with Morris.
Gene, one of the things would be wonderful to have is a written history of the department. And,
I'm in the process of writing a history of the department. Yeah, it will not be comprehensive. It won't be long. But I agreed to the current Dean of Science, Bob Silby, who won't be Dean for much longer, about a week. I agreed a few years ago to write a history of the department, and I've almost got it finished. I still have to go back and write up the education part, which I haven't done yet, but I've written about the faculty at least. And it won't be long, but it's very terse and not lengthy. Mm-hmm.
You mentioned you never lost your temper in 16 years, even when provoked. So how did you get that steam out of your...
How did what?
How did you relax, or how did you... Right.
How do you... Well, I just keep telling myself, don't lose your temper, don't lose your temper. That's right. I still tell myself that. I particularly tell myself that about dealing with students nowadays. Some students really provoke me, particularly when they get a D when they think they should have got a C.
Alice, you mentioned how there's been
I'm sorry.
You mentioned how there have been more females over the years, both as faculty members and as undergraduates, and I was just wondering whether you could comment on how that process came about, if there's resistance or changes in the atmosphere from that.
How did it come about? Well, it came about gradually. There was never, I mean, MIT has always been a co-ed institution, always, from its first inception, a co-ed institution. It's just that it was primarily an engineering school for so long, and for all those years, females didn't enter the engineering profession. Reasons, I don't know. But the fact that it was primarily an engineering school led to there being very few female students here. And it was only after the School of Science started getting larger, chemistry department, biology department, physics department. Physics is still primarily male, but chemistry and biology started and more females wanted to enter chemistry and biology, and so it became possible. And I should point out to you also that the Sloan School became prominent, started to become prominent too, and females were interested in business. And then we do have, of course, a good humanities and social science school at MIT as well. And it's become much better than it was when I came here. And I think a lot of women students like to take courses over in the humanities and social science school. And women have, we have more female biology majors as undergraduates now than we have males. And I think the same is true in chemistry. So it was a gradual process. I don't think anyone made any huge effort. I don't know of any huge effort that anyone made to admit more female students. It's just that female students began to apply to MIT in greater numbers. And I will have to tell you, and I hope I don't tromp on any toes here, that I think the female students are much more willing to make the effort in classes than male students are these days. I'm not sure why that's the case, but it's just an impression that I have.
A question following up that. So there's definitely more female undergrads in biology, but we don't see as many in terms of ratio of female faculties. Do you think that will change gradually as well, or some effort?
Oh yes, I think it will. It's changing. It is changing gradually. I mean, we have more female faculty members now than we had 10 years ago, for example. And yes, it is changing gradually. And we have a lot of very, very good female candidates for faculty positions these days. A lot of them. When old geezers like myself and Boris were no longer available, and Maury, and when females will replace us, perhaps. Anything else? Well, thank you very much for your attention and for showing up. And